Okay, in this section, 1-4, we are looking at the topic of the segment addition postulate. And before we get into the segment addition postulate itself, we need to kind of talk about a little bit of background information here. And so, suppose I'm looking at these two segments. So here, based on the lesson that we had last time, we know that this is segment AB, and this segment is segment CD. So we're looking at two segments. Let's say they both have a length of 5, and 5 whatever units you want to use, feet, inches, whatever the case may be. So they're both 5. Okay, so they're the same length. Okay. With regarding the notation, remember, when you write this, this is a segment. Okay, and a segment is an object. So if it's got that segment symbol over it, you're talking about the segment AB, the object itself, right? Now, if you just write AB and you don't put the segment bar above it, you don't put any object symbol above it, then you're talking about the measure of segment AB, and the measure is a number. Okay, so how long the segment is. So when I write this, I'm talking about the segment AB, the object itself. When I write this, I'm talking about the measure or the length of the segment AB. All right? So the segment is this. Okay? The measure of the segment is 5. All right? So keep that in mind. Okay? And that brings us up to some more symbolism that we want to look at. Okay? So this symbol right here, as you all know, is equal. Well, what's equal used for? It's used between two numbers that are the same. Right? It's used between two numbers that are the same. Okay? Now, this symbol is called congruent. This symbol is called congruent. And congruent is used between two objects that are the same. Two objects that are the same. So, the difference between the two is you use equal for numbers and you use congruent for objects. And so, remember, if I were just to put these two here like this, right? Remember, if I just write these two letters without any symbol above it, I'm talking about the measure. And remember, what's the measure? Is the measure a symbol, or excuse me, is the measure an object or a number? Okay, so the measure is a number. Well, what should I use between two numbers that are the same? I should use an equal sign. All right? Here, if I were just to write these two out, okay? These two are segments. Well, segments are objects. Well, what do I use between two objects that are the same? Congruent. So two numbers that are the same are equal, but two objects that are the same are congruent. All right, so keep that in mind. So between 5 and 2.5 times 2, I would put equal. Between 10 and 12 minus 2, I would put equal. All right, between 3.14 and pi, I would put equal because those are two numbers that are the same. Okay? But between two segments that have the same length, I would put congruent because they're objects. Between two angles that have the same measure, I would put congruent because they are the same. Between two pencils that are exactly the same, I would put congruent, okay, because pencils are objects. So I would say that these two pencils are congruent. That means they have the same size and the same shape. All right? So keep that in mind. Equal is for numbers, congruent is for objects. Okay, so now there is one more definition that we want to take a look at. Let's say I have a segment that's drawn like this. And I label this thing as A, B, and C. All right? What we can now say about this segment is that point B is between A and C. Point B is between A and C. Point B is between A and C. All right? So if point B is anywhere on this segment, then point B is between A and C. So the definition of between is it's got to be a point that's on the segment somewhere within the endpoints. So if point B was off the segment, it's not between. All right, if it's right here at the endpoint, it's not between. And certainly if it's way out here somewhere, then it's not between. So between means on the segment, somewhere inside the endpoints. Okay? Now, we're ready to look at the segment addition postulate. Okay, so my segment addition postulate, which by the way, this word postulate is just a word that means a mathematical statement. So in geometry, especially, is kind of the first math course that you come to where you're looking at a lot of mathematical statements like theorems and postulates and corollaries. All of those are mathematical statements. So one theorem that you all know is the Pythagorean theorem. That's a mathematical statement. In a right triangle, all the sides, if C is the hypotenuse, a squared plus b squared equals c squared. Mathematical statement. Postulate, also a mathematical statement. So here's the segment addition postulate. It says, if B is between A and C, if B is between A and C, then the measure of AB plus the measure of BC equals the measure of AC. So let's draw that out and see if that's true. All right, so let's draw a segment. Let's draw segment AC. And let's draw B between A and C. So remember, if B is between A and C, it's got to be on this segment somewhere, all right, within the endpoints. So, by the way, between does not necessarily mean right at the middle. That's midpoint. Between just means anywhere between A and C. And so let's say my point B is, let's go with right here. Here's point B. All right. And let's say the length from A to B is 8. And the length of BC is 4. Well, if that's the case, then the length of AC, the whole thing, has got to be those two added together. Okay? So the whole thing has got to be 12. So again, segment addition postulate says if B is between A and C, then this piece plus the other piece adds up to the whole thing. This segment plus this segment adds up to the entire segment AC, which makes sense. This part plus this part should equal to the whole thing, and it does. All right? So that's the segment addition postulate. Each piece can be added up to the bigger part, the bigger segment. All right? So that is the segment addition postulate. Now, let's see if we can use the segment addition postulate to actually answer some questions. All right? So here is the first question. It says U is between T and B. U is between T and B. Now remember, when it says U is between T and B, then what kind of objects are we talking about? U, T, and B. They have to be points, because remember, points are named with one letter. Keep that in mind. And it's asking us to find the length of segment TU. All right, so if you tried to do that, and underneath that, it gives us the length of UB, and it gives us the length of TB. And based on that, we want to find the length of TU. Now, some of these, it can be difficult to visualize in your head. So what really helps out tremendously in geometry in general is to draw it. If they don't give you a picture, then you draw a picture. So what do I need to draw? I need to draw U is between T and B. So let's draw that. All right, so here is T and B, and we got U between T and B. U is between T and B. All right, so let's label the parts they give me. UB is 18. TB, that's the entire thing, 24. And then the question is, how long is TU? Well, once you draw it, you can see that this is the missing part, and this piece is 18, the whole thing is 24. Remember, segment addition postulate says this plus this should equal to 24. So what plus 18 makes 24? Well, if you just subtract, you'll have your answer. 24 minus 18 makes TU have to have a length of 6. So 6 is the correct answer there. All right? So again, take it, set it up with the segment addition postulate, and then you will be able to figure out the value of the missing piece. All right? Now, it's not always just regular numbers. One of the reasons why the last lesson was setting up and solving equations is because, look, now you've got pieces of segments in terms of x. So let's see what happens. So the directions are the same for all these problems. U is between t and b. So let's draw it again. Okay. U is between t and b. Now let's label the parts. Tu is 4x. Ub is 2x. Tb is 18. All right? Now, from here, what we're going to have to do to figure out the correct answer is we're going to have to set up and solve an equation. Okay? Now, once we solve an equation, here's the thing. They're asking me to find Tu. Tu is 4x. So in order to figure out how long Tu is, I need to find the value of x. Once I figure out the value of x, I can plug it in here, multiply it by 4, and that'll tell me how long Tu is. Okay? So solving this problem depends upon finding the value for x. Right? So what can we do to find the value of x? Well, if you want to figure out what x equals to, then you can set up an equation. All right? So let's see if we can set up the correct equation here. This is where the segment addition postulate comes in. Because remember, what does the segment addition postulate say? It says that this piece plus this piece equals the whole thing. Well, that sounds like an equation to me. Let's write it. This piece, 4x, plus this piece, 2x, equals to the whole thing, 18. So now we've got an equation that we can solve for x, and we can take that value of x and plug it back into Tu and get the answer. So now this is the equation that we have to solve. Where did we get this from? This piece, 4x, plus this piece, 2x, equals to 18 by the segment addition postulate. All right, so the last lesson we reviewed solving equations. Well, what do I need to do? I can add these two x's together. What's 4x plus 2x? 6x. Equals 18. Now I'm ready to divide both sides. We can divide it by 6. And then I'll have x is equal to 3. Now let's stop here for just a minute. 3 is not the answer. 3 is not the answer. Because the question didn't say to find x. The question says to find the length of Tu. Now I can use x to help me find Tu, but remember, x is not the answer. That's not what they ask you to find. I can now take 3 and plug it in here. Well, what's 4 times 3? 4 times 3 is going to give you 12. And then so I know that Tu is equal to 12. So 12 is the correct answer. If you want to make sure that it makes sense and your answer is right, plug 3 here. What is 2 times 3? 2 times 3 is 6. We already know that's 12. What's 12 plus 6? Better be 18 if we did it right, and it is. So you can always double check. Okay? And plus, you might have a question too that says to find the length of segment UB. Then you can just plug it into whichever part they ask you to find. Okay? One more practice problem that we need to look at. Once again, the directions are the same. U is between T and B. And so what that means is I've got my T here. I've got my B here. U is between those two. And let's label the parts that they've given me. Tu is 4x minus 1. So I'm going to put 4x minus 1 right here. Okay? Ub is 2x minus 1. So I'm going to put that here. Tb, the whole thing, is 5x. The entire thing is 5x. Okay? Now that I've labeled it, I can now use the segment addition postulate to write an equation. Remember what the segment addition postulate says. It says this piece plus this piece equals to the whole thing. So here's the equation that I need to write. 4x minus 1 plus 2x minus 1 equals to 5x. So remember, this piece plus the other piece equals the whole thing. That's where we generate our equation from. Okay, so now it's just a matter of solving it. So remember, I can combine like terms, put all the x's right here together. So what's 4x plus 2x? That'll give me 6x. Then I have negative 1 minus 1. That's negative 2. If I owe you $1 and I owe somebody else $1, now I owe $2. Equals to 5x is staying put. We haven't moved it yet. But we are going to, because now that I've combined the like terms, I need all the x's on one side and the regular numbers on the other side. So 6x is going to stay put. 5x is going to join it. It's going to change from plus to minus 5x. The 2 is going to the other side. It will change from minus 2 to plus 2. And then so now moving those two terms gets me closer to what I need to solve for. 6x minus 5x is just x. And because remember, 6x minus 5x, 1x. If you just write x, how many is that? That means 1. So you don't have to write the 1 out beside of it. So that'll be 2, x equals 2. And that's the value for x. Notice I did not say that's the answer. One thing that you need to make sure you keep in mind in geometry. Okay, don't be working problems. Oh, there's my answer 2. Well, guess what? On a multiple choice, 2 is going to be the very first answer and you're going to get it wrong. Okay, because remember, they didn't ask you to find for x. Okay, they asked you to find the length of TU, so we're not done yet. So always make sure that you answer the question. Otherwise, you run the risk of getting the answer wrong. All right? They didn't ask me for x. I have to take this x now and plug it back in here. All right? So when I do that now, it's going to be 4 times 2 minus 1. Because in place of x, what do I put? I put a 2 in place of x. 4 times 2 is 8. 8 minus 1 is 7. TU is equal to 7, and we have the right answer. If you want to go all the way through and put in 2 right here, that's 4. 4 minus 1 is 3. And if I put 5 times 2 right here, I get 10. 7 plus 3 makes 10, and it works out. All right? So keep that in mind. By the way, something else that I may want to show you here. TU is equal to 7. That's the correct answer, and that's also number 5 on your quiz. So if you're paying attention closely in the notes, you may notice that sometimes, occasionally, we will do one of the problems from off of the quiz in the practice problems. Right? So just keep that in mind and be aware of that. You already have the answer to number 5 on your quiz. It's 7. All right? So take what we've learned here, apply it to the quiz problems, and make sure you get all of those completed, the 2 quizzes for today before midnight. All right, I'll see you in class.